So you're about to play our game of periodic dinner table bingo. So the aim of this game is to take your periodic tables and spot where we interact with different elements throughout our show. So for example, if we take some cutlery is made from stainless steel, so that's got iron and chromium in it. And so you're going to have to find iron and chromium on the periodic table, tick them off, okay? Now, the aim then is to try and complete a row, or a period, as chemists prefer to call them, and a column, or a group, as chemists prefer to call them, and also try and spot the heaviest element that we interact with. And then actually afterwards, we'll give you the results, see where those elements were, and you can check if you got everything right. Right, let's get on with the show. Right, I wonder where Phil is. Been waiting ages for him. Oh, I think that's him on the phone. Hey Phil. Yeah, I'm good. You're just round the corner. Brilliant. Okay, I'll see you in a second. Oh, just a minute. Phone's almost flat. Oh, let me charge it. Let me just charge it up with my lithium-ion battery. There we go. Right.
Hello, Mark.
Hey Phil,
hey,
it's great to see you.
Oh, it's lovely to see you too.
Oh, wonderful.
Let me get that. Happy birthday. I've got you some balloons.
That's brilliant.
You wouldn't happen to have a pen, do you?
Yeah.
By any chance?
Yeah, so yeah, it's my nice fountain pen.
Oh,
actually.
Wonderful. That's a really lovely pen.
Yeah. Actually, did you know that the pen nibs have got osmium and iridium in them?
Really?
Yeah, it makes them for really hard steel nibs. Yeah. Anyway.
Well, anyway, happy birthday.
Well, thanks. It's good to see you were really well prepared. Yeah. Cheers, Phil. That's lovely. Thank you very much.
So how are you doing?
I'm really good, actually. Yeah, it's been ages, hasn't it?
Oh, definitely over a year.
Yeah, definitely. Anyway, but we settled in. Would you like a drink?
I could actually am a bit parched. What are you gonna have?
I'm thirsty as well. I'm just gonna have some H2O.
How are you?
Yeah.
I guess I'll have some H2O too.
Okay. All right. Hold on a minute. Let me just get that for you. Okay. Oh, by the way, in case you need Wi-Fi, Wi-Fi passwords there. Okay, on my nice chalkboard.
Oh, well, yeah, very rustic.
Yep.
It's a bit dark. Mark, your lamp doesn't appear to be working. Don't you have any other?
Yeah, there's a bulb down on the table there.
Fluorescent bulb. Very nice. Better than this tungsten one.
Yeah.
Let's see that. Oh, no, wrong fitting.
Don't worry about it. We'll work it out. Anyway, here we go. My water and your hydrogen peroxide.
What?
H2O, hydrogen peroxide.
No, you said H2O. I was like H2O.
Oh, as well.
Right. Which one's the water?
I'm not sure now.
So we have one glass of water and one glass of essentially bleach.
Yeah.
Is there any way to tell which one is which?
There is a really cool way to tell. All we need is a bit of washing up liquid.
Okay.
And some yeast.
All right. Well, I'll look for the yeast. I think I can see some here. I don't suppose you have some implements to cut it. Maybe a pair of
scissors.
Scissors.
Okay. Which have got vanadium steel packed in them. Anyway.
Is that anything like Valerian steel?
No. Right. So what we need to do is put a bit of washing up liquid in that one, and a bit of washing up liquid in that one. Right. Just give it a bit of a mix around.
Right.
Okay. And then I'll dunk in some yeast in there, and some yeast in there, and give that a mix as well. And can you see how this one is foaming?
Oh yeah, very gradually.
Yeah, there you go. You see it there?
Yeah.
So that one is the hydrogen peroxide.
There seems to be some steam coming off.
Yeah, that's right. It's because it's an exothermic reaction, so it actually heats up quite a lot and generates steam as well. And in fact, there's the bubbles then contain oxygen. So hydrogen peroxide, handy molecule of here, is 2 oxygens, 2 hydrogens. And what the catalase, the enzyme in the yeast is doing is it's removing that oxygen, that becomes water, and then you get oxygen liberated that's in the foam.
That's very interesting. So we now know that this is bleach, and we now know that that is water. But what we definitely know is that they're both undrinkable. Yeah. Because they now got both yeast
and
So no offense, but I'm gonna pass on the water for now.
Okay. Well, all right. Well, I'll take this away then. What would you like instead?
Well, what have you got?
I've got some Coke.
Okay.
Or I've got some if you prefer some wine.
See, I'm slightly allergic to sulfite, so I'm gonna.
Okay. Yeah.
I'm gonna pass on the wine, but some nice Coke containing. Ooh, phosphoric acid.
Phosphoric acid.
Wow.
That gives it the nice tart taste as well.
So before we go any further, because it is your birthday, because it has been a while, I do have a little bit of a surprise for you.
Oh, really?
Yes, I have bought you a little gift.
Oh, Phil, that's really nice of you. Oh, wow. Oh, wow, that is beautiful. It's a green, antique green glass.
Well, it's more than just a green glass. See, there is an element from the periodic table that this glass has in it. Okay. And I can show you with this torch, which
isn't working.
Don't worry, I definitely brought some spare batteries.
Have you got the new and the old batteries mixed up?
A little bit, yeah. Can you?
Yeah, actually, there's a really easy way to tell whether batteries are charged. Whether they're charged or discharged or flat. And basically, dead batteries bounce. Okay, so if I take these batteries and I drop them on the table like that, did you notice how that one bounced and this one didn't? And that's because in these batteries, there's the electrodes, that's manganese and zinc, and they are encased in an electrolyte, it's a gel, and that electrolyte turns to a ceramic as it discharges. And as if anybody's ever dropped a plate, you'll know that ceramics bounce and jellies don't. So that's how you tell the dead battery bounce.
Well, I was actually going to say the easier way is just to press either side of the battery, and that bar in the middle actually says it's. But anyway,
as well.
So now that we have the UV light working, have a closer look at the glass. When I shine the UV lights on.
Oh wow! It fluoresces green.
Fluoresces green due to the element that's inside of it.
Excellent.
So I thought you would find that particularly entertaining.
That is really beautiful. As a chemist, I mean that's right up my street. That's really lovely. And I know it's my birthday, but we've missed yours. So I got you a present as well.
Oh, Mark! You really didn't have to. I'm slightly embarrassed.
I've got you some
anti-dandruff shampoo.
Yeah.
With extra selenium sulfide.
Yeah. And it's right, it gets better. I've got some mouthwash as well.
Right. You really shouldn't have.
Well, yeah, I thought it just might be handy. No? Okay.
Okay. Well, so I figured as well, seeing it's been a while, I thought I would try and entertain you a little bit. I've learnt a card trick for you.
Have you?
Yeah,
brilliant.
You know I like my card tricks.
I do know you like card tricks.
And this is a very special one because it's simple. It only requires 6 cards. And you can see the 6 cards here. Yeah. Now, Mark, all I want you to do is I just want you to point to any card that your heart truly desires.
For the 5.
You're going to go for the 5, you sure? You can change your mind if you want.
No, 5's fine.
5 is good. So we'll put the 5 there. Now I'm going to show you that I have here 5 green backed cards. And out of all these green cards, you managed to pick
the only blue card. Okay, yeah. 1 in 6 chance. Yeah.
Well, it might seem like it's 1 in 6, but if you pick a different card.
Okay, I'll go for the 6 this time.
I'm going to go for the 6. We know that this is going to be the green card.
Yeah.
But actually what happens is that all these cards now become blue.
Oh, wow.
So we have 5 blue back cards, and you still pick the golden card.
That is very clever.
It's one of those tricks where the cards are always stacked against you, Mark.
Yeah. Well, actually, before you put them away, they look like some really nice new cards.
Oh, yeah, they've got that lovely titanium oxide smell to them.
Yeah, so in fact, actually, that's what makes these cards really beautiful and white, and in fact, they fluoresce as well. Look.
Oh.
Yeah.
That's very interesting. I'll have to remember that next time I do a card trick.
Indeed. Right. Anyway, we never got our drinks, did we? I'm gonna have a tonic.
No, of course. In fact, speaking of tonic and still using the UV light, there's an extra little thing you can do using that glass. You see, as well as the element in this glass that makes it fluoresce green, the tonic has a chemical called quinine, which also fluoresces but blue.
Oh wow!
So now
a green and blue fluorescent drink. That is now my new favourite tonic.
I thought it would be. So you've seen my card trick. Don't suppose there's any new science trick you've learned?
Oh, I like been practicing my tricks as well. Actually, I'm going to use your pewter mug there. And what I've got here is I've got a couple of forks that are jammed together, and I've got a toothpick there. And if I just balance that, there we go. Look at that.
Oh, it's balancing.
Yeah. Now, looks like it should be completely, impossible, doesn't it? But, in fact, look at that there. It's balancing right on the point there, and it looks like all the weight's over this side of the forks. So how does that work?
I mean, that's another thing for a physics show, I think.
Yeah, or a physics teacher. Maybe.
Yeah, maybe.
Could explain it.
But it does seem like you could have used your glass. It didn't seem like you have to use my lovely pewter mug
Your
here.
pewter mug.
Yeah.
Well, I didn't want to risk damaging my nice lead crystal there.
I guess that makes sense.
Okay. Right.
Should we have some food?
Yeah, sure.
I must say, Mark, I'm really enjoying this table spread. Like, you've got your chemicals here. What's this?
It's none of your bismuth.
Okay, fine. I'll put it back.
Okay.
Oh, you use scissors to cut pizza. Do you know how to pizza cutter?
Wow, what's the matter with scissors? There we go. Okay, excuse my fingers. There we go.
Don't suppose you've got any salad?
Yep, there's some salad down here.
Ah, brilliant. Do you know that they actually how they preserve the salad in those bags for so long?
I do. They're packed under an inert gas.
Yes.
Again, excuse my fingers. I'm going to go through.
It's fine. As long as you've washed your hands.
I have. Yep, I did beforehand.
So, speaking of more sciencey tricks, I actually have another science trick for you.
Oh yeah.
And all I need is some pencils. Would you mind giving those a quick sharpen for me? They need to be extra sharp.
Really, really sharp pencils with this. What alloy these pencil sharpeners are made out of?
Well, it's a very special one. Magnesium.
Magnesium alloy?
Yeah, magnesium alloy. And next up, we need a Ziploc bag of water.
Okay, right.
I'm going to take the pencil and I'm going to put it through this bag.
And you're going to cause water to leak all over my... Yeah, I'm really looking forward to this.
Or am I? You ready?
Yeah.
Here we go. Just like that.
Very good.
Now see, as the pencil goes through, it's actually plugging up the holes in the Ziploc bag.
Very nice.
So we can do this again. We can actually get quite a few.
Yeah, I didn't sharpen that one. Okay.
I'll put it through anyway, so there you go.
Very nice.
Little
What are we going to do with that now?
Well, I mean...
I'll best just take it back to the kitchen.
Yeah. Yeah, it is a bit of a slightly more messier one, though.
Right, okay, we're on a roll now, Phil. So my trick, give us that bottle of Coke.
My Coke, yeah.
Right, then you can take a straw. I'm going to put the straw on top like this, and if I wave my hands near it, with my powers of telekinesis, I can make the straw move around. How cool is that?
That is very cool. Wait, how are you doing that? You need to tell me how you've done that.
I don't know. Do I? Or should we leave it in a mystery? Okay, I will. Strangely not, it's not telekinesis. It's static electricity. What you didn't see is me charging my straw a few minutes ago by rubbing it on my head, put it on the top there, and then you can just make the straw move by static. There we go. How cool is that?
Oh, that's brilliant.
Isn't it? Right.
I never knew you did magic as well, Mark.
Yeah, well, I'm more like science tricks, really. Anyway, right, actually, Phil, I do have another present for you.
Oh, really?
I'm sorry I played the rather cruel joke on you.
That was just a prank present?
Yeah, I've got something really, really neat for you here.
A spring!
Yeah, a spring. This isn't any spring though, this is really quite an unusual spring.
A broken spring!
It is, but hang on to that a minute. I'm going to go and fetch some boiling water and I will show you something really cool that spring does. Okay? Bear with me.
I shall just sit here and
There we go. Some boiling water. Right, I'll just put that in the glass. That there.
And
Yeah,
what do you want me to do with this?
Wait a minute. Let's just. I'll just get this out of the way. There we go. Now take your spring and just dip it into the water.
Oh wow! Is that resetting itself?
Yeah. Look at that. Put it back out. It's a spring once more.
Is that a memory metal?
It is. It's memory metal made out of an alloy called nitinol.
What's nitinol?
Well, it's made of nickel and titanium in special format, and you can program it, if you like, with a particular shape, deform it, and then when you heat it up, it takes that shape back on again. And it's used in all sorts of things, not just for novelty magic springs, but it's also used in things like stents in heart surgery. So, for example, if you're a surgeon, you want to get the stent into the middle of the heart. You don't want to open up the whole chest to get it in there. Instead, maybe you could pass a long, thin stent through arteries and veins to the heart.
Right.
Then you heat it up with a bit of electrical current, and it expands out and opens up the blockage.
Oh, that's
cool.
really brilliant.
So it's, yeah.
Actually, that is a neat gift. I take it back. Thank you for that.
You're very welcome.
I'll add it to the shampoo and
Anyway, we haven't had any of our...
oh, lovely pizza.
Big pizza. Yeah, right. One more for you, Phil. One more trick for you.
Oh, go on then.
Okay. And then we'll be done. Right. Here's one for you. Empty bottle.
Yep.
Penny.
Yep.
Okay. Watch carefully. 1, 2, 3. And now the penny is in the bottle.
I mean, that's not very impressive. There's clearly a slit somewhere in the bottle.
Well, can you find it?
I cannot.
Okay, so I'm going to give you a choice now. Would you like to be left in mystery, wondering forevermore how that trick was done, and and we can follow the magician's code of never revealing their tricks? Or would you prefer me to be a scientist?
Be a scientist.
Okay. And scientists, of course, explain what's going on.
Yeah,
Right.
I need to know how this works. Be a scientist.
First question for you then. What's this? These pennies. What are pennies made out of?
Well, it's copper, isn't it? Because they're copper coins.
Well, they're actually copper plated. Yeah. The most of the coin is actually steel. Yes.
Oh.
And steel is magnetic.
Magnetic, yeah.
And I've got 2 rings on. I've got my gold wedding ring, but I've also got this ring on, which is magnetic, and the penny sticks to my magnetic ring. So this is a rare earth magnet.
Oh, it's one of those super strong magnets.
Yes. Yeah.
Oh, can't quite remember what that is.
No, you have to go look that up and Google it or something.
Oh, anyway, the Wi-Fi password, don't tell me.
Yeah, that's right. So there's a penny in the bottle.
Right.
And it sticks to my ring, and it's hidden behind my hand. And then I have a second penny, and I go 1, 2, 3. And whilst I'm shaking that, I'm pulling this away, and there's the penny in the bottle trick.
You know, part of me is honestly can't believe I fell for that. That is a really neato trick, isn't it?
Yeah. What was that beeping?
Is that your fire alarm, Mark? Do you need a new battery?
I will get that in a second. Anyway, before you go though, before I forget, I need a photograph.
Right,
Okay. Yep, just pose nicely. There we go. Okay. Nice old film camera. This one of my favourites.
I do remember you do have a liking of film cameras, don't you?
With good old silver halide films, and there's nothing quite like it. Much nicer than the new digital versions. Anyway, did you hear that beeping again?
I did hear a beep. I think it's your fire alarm. Actually.
Oh yes, it's the beep, the fire alarm, so it makes it when they go. Oh yeah, yeah, the battery's definitely there. It is again. Battery's flat.
I mean, that doesn't seem like a good place to have a fire alarm anyway.
But anyway, look. The thing is, smoke detectors, they have an element, a man-made element in them. Yeah, one you find way down the bottom of the periodic table, and it's named after America. There's your clue. Okay, but we better undo that and I'll
again
sort that out later.
Maybe install it a bit higher.
Yeah,
up.
okay. I know I've been a bit lax with that. Yeah, maybe my fire safety isn't all it's cracked up to be. But
especially if it's down there.
it's a bit of a shame really, because I've also got us a birthday cake, and
right.
we best not we best not use it in here, like the candles in here though.
Is it this birthday cake?
Yeah, that's the one.
Oh.
But maybe we best take it outside. And
Yeah,
candles up there.
because of the fire alarm.
Yeah.
That's probably a good idea.
Okay, come on then.
Come on then. I'll carry the cake. There you go, Mark.
Oh, cheers, Phil.
Ooh.
Right, let's have this cake.
Yeah. Have you got a lighter of some sort?
Yeah, here we go. Let me just light these. Okay, so we can get this delight outside here. We've got a...
Hang on. Is the flames also coloured the same as the candles?
Yeah, that's right. So you've got an orange, you've got a red flame, a blue flame, a green flame, yellow flame.
Is this all like the base of the flame test?
That's right. So they've got different metal salts embedded in the candles, which means that the candles burn with different colours. So if you remember your flame tests, you'll know which elements are within the candle. Anyway, let's just put these out. Okay, there we go.
Excellent.
And
So
have some cake.
some cake. Okay. If you, I'll get rid of that one. So let's give it.
Here you go. Take that spoon.
Oh, that's a bit of a. It's a bit of a dirty. Is this a silver spoon?
I think so. Yeah.
It's a bit tarnished.
Oh,
Do
sorry.
you know how to clean a silver
Oh,
spoon?
there is that really neat way of cleaning silver,
Yeah.
isn't it?
Do you have any hot water?
Yep. There's a kettle just over here.
So if you fill that up with hot water, so now all you need is some aluminium foil and some baking powder.
Okay. So
And just put it in.
Put a bit of aluminium in. Yeah. And a bit of bicarbonate of soda. In fact.
And now all you have to do, once you've got
Right.
those in, is just dip your silver spoon directly into it, just like that, and give it a stir. And,
Phil, the spoon's melted, mate.
how hot is that water?
That is mad.
Like, ooh.
Whoa, totally melted. So the thermometer says it's only about 40 odd degrees. So
Must not be a silver spoon after
can't be
all.
silver at all. Must be some other metal that melts a much lower temperature. Weird.
Weird that.
Yeah.
all
Anyway,
right,
well, don't worry about that. Let's just cut the cake and. We'll cut it.
Well, I have to take mine to go.
Okay then, yeah, we'll have it in a bit. And actually, before you do have your cake, I have actually got you a really decent present. Okay. Yeah. Here we go. If you look at this,
Is that
who signed that down the bottom there?
Marie Curie?
Yeah, there's actually a certificate signed by the Marie Curie. Okay. She discovered polonium and radium, so there might actually be some radium on there. Yeah.
I've now got a signed Marie Curie certificate that might also be radioactive.
It might be, but don't worry, it's behind the glass. That will absorb anything, so it's perfectly safe. How cool is that?
That definitely makes up for the shampoo and the Listerine. I must say.
Well, it's been great seeing you again, Phil.
It's been great to see you too.
Let's catch up again soon.
Yeah, we'll have to do it again.
All right.
All right.
Cheerio, mate.
Just gonna take the whole cake.